So in the previous lecture, we have seen about the wind pressure on structures. Okay. So we have seen an introductory part about how to calculate the resultant wind force, how to calculate the self weight of the structure, and then finally how to calculate the maximum stress and minimum stress. Now we'll be seeing one problem in this lecture. So a masonry wall 10-meter high, a masonry wall 10-meter high, 3-meter wide, and 1.5-meter thick is subjected to wind pressure of 1200 Newton per meter square on 1.5-meter side. Find the maximum and minimum stress. Find maximum and minimum stress if unit weight unit weight of masonry is 20 kilonewton per meter cube. So this is the question. So in this question now we'll quickly draw the diagram. So a wall is given, masonry wall. So we'll draw the plan also, top view, and this is the centroidal axis. So now the dimensions of this, it is 10-meter height. So the height of the wall is 10 meter. Now the width is 3 meter. So this is 3 meter and this is 1.5 meter. Now it is subjected to wind pressure of 1200 Newton per meter square. So there is a wind pressure here which is acting, and the intensity of this is 1200 Newton per meter square. Now what we have to do? We have to find out what is the resultant wind force, that we have to find out, capital P. And one more thing is given, unit weight of masonry is 20 kilonewton per meter cube. So let's start the problem now. So first given, so in given the height is given here 10 meter, B is 3 meter and D is 1.5 meter. Then wind pressure is given, small p, that is 1200 Newton per meter square, and density of masonry is given. This will represent by rho, and this is 20 kilonewton per meter cube. So these are the things which is given. Now what we have to find here? We have to find same two things, sigma max and sigma minimum. Now To find out sigma max and sigma minimum, we'll go step by step now. First, we'll find out the value of capital P. Capital P, that is the resultant force. So resultant force is equal to intensity, wind pressure intensity multiplied by the area of the surface. So here the wind pressure intensity is 1200 and the area of surface. This area is nothing but हा area म्हणजे ज्या एरियावर हा wind pressure act होता है. Okay. So this height is 10 meter and the width is 1.5 meter. Okay. असा surface राहील हा. So 10 into 1.5 will be the answer here. So 10 multiplied by 1.5. So if we do this multiplication, we'll get the answer as 18,000 Newton. Now next thing what we have to see is the weight. What is the self weight of this? So we'll represent the self weight by W. Now how to calculate this W? W is equal to density multiplied by volume. Density multiplied by volume. Now density is given here 20 kilonewton per meter cube. So it is 20 kilonewton. Will convert it into standard SI unit. So 10 to the power 3. This multiplied by volume. So volume is length into breadth into height. Length into breadth into height. So this we will get 900 into 10 to the power 3 Newton. This we can write it as 900 kilonewton. So now we have got the P value and W value. So we have got the P value and W value. This distance is 5. Now we have to use the main formula, that is sigma max is equal to sigma naught plus sigma B and sigma minimum is equal to sigma naught minus sigma B. So first we will calculate sigma naught, that is direct stress. Direct stress is equal to W divided by A. So weight divided by area. So what is the weight here? 900 kilonewton. So 900 into 10 to the power 3 Newton divided by area. So the area is 3 into 1.5. So 3 into 1.5. So if you do this calculation, you should get the answer as 200 kilonewton per meter square. Similarly, bending stress sigma B is equal to m by z. M is equal to P into h by 2. Movement will be due to the wind force and that is equal to P into h by 2 divided by z. Now z is in this case dB square by 6. So we'll substitute all values here. So P is 18,000 Newton, or we can write it 18 into 10 to the power 3 into h by 2 is 10 by 2, that is 5. Then D is 1.5 into B3 square divided by 6. So this is the value of sigma B and sigma B will come 40 kilonewton per meter square. So now we have got both the values. Substitute it here. Sigma max is equal to sigma naught plus sigma B, that is equal to 200 plus 40, that is 240 kilonewton per meter square. As it is coming as positive, so it is compressive. Similarly, sigma minimum is equal to sigma naught minus sigma B. Direct stress minus bending stress. 200 minus 40, that is equal to 160 kilonewton per meter square. This is also coming as positive, so this is compressive. In this way, we have calculated the maximum stress and minimum stress for the masonry wall. Now just pay attention here. Whether the masonry wall is given or chimney is given, chimney is also nothing but a tall structure which is having circular cross section. याचा क्रॉस सेक्शन जो आहे तो कसा राहणार आहे, सर्क्युलर राहणार आहे. सो ओनली डिफरन्स विल कम इन दिस एरिया पार्ट. So this will be the cross section. Rest all the calculations will be same. The calculation of self weight and also the calculation of wind force.